Hi, we all know plastics are hard to decompose, but do you know that plastics are not only hard to degrade, but they can also break down into many micro-sized particles in natural environment? And do you know how material flow analysis approach can help us to be mindful of the materials we use on a daily basis, such as plastics? We are Eric, Polly, Calvin, and Ricky, and today we'll take you with us to learn more about microplastics. To dive in, we need to first get an idea on what plastics are made of. Plastics are synthetic polymers, chains of carbon atoms addition with other elements such as oxygen and nitrogen. Commonly used polymers are polyethylene used for plastic bags, polypropylene can be used for disposable food containers, polystyrene, polyvinyl chloride, polycarbonate, polyamide can be used for fishing net. Plastics are lightweight, high strength, resistant to corrosion, inexpensive. However, plastics polymers are highly resistant to degradation in natural environment. Their treatment can cause pollution and have high recycling costs. It can also kill animals by ingestion or entanglement. The process of plastic polymer can take up to centuries to finish. Most common methods to dispose plastics waste are recycle, incineration, and landfill. And common pathways for plastic degradation are thermal degradation, photooxidative degradation, mechanical degradation, chemical degradation, and biodegradation. Microplastics are particles with diameter less than 5 millimeters. Some microplastics particles occur during the degradation process, and on the other hand, some of the microplastics are manufactured intentionally. Those are called primary microplastic. Examples are resin pellets, vectors in drug scrubbers, and in personal care products. Those that are fragmented from larger plastic products are called secondary microplastics. Studies have shown that primary microplastic emission in China was over 700 gigagram in 2015, and about 120 gigagram entered the aquatic system. Microplastic particles are not only prevalent in the aquatic system, but also soil and even frozen ice in the polar regions. Plastics accounts for about 70% marine debris. It is expected to contain 1 ton of plastic for every 3 tons of fish by 2025. But by 2050, there will be more plastics than fish. Plastic materials, such as plastic bottles, enter the aquatic system. Debris gradually degrade into small plastic fragments due to ultraviolet radiation and mechanical degradation. Microplastics smaller than 1 millimeters are similar in size to food organisms such as zooplankton eat. Plankton from the SpongeBob. First traces of microplastics in the oceanic ecosystem are shown from those organisms. With nature taking its course, small fish eat zooplanktons. Large fish like tuna or salmon eat small fish. Microplastics can have widespread impact in all types of aquatic organisms by moving up from the food chain. And you know what eats large fish like tuna or salmon? You guessed it, sharks, seal, and us humans. It's safe to say that there are traces of microplastic particles inside most of us. Even that being said, the exact harms that are caused by microplastic particles to humans are still relatively unknown. Sewage effluent has been identified as a major source of microplastic fibers to the marine environment because it concentrates and delivers particles derived from washing clothes and textiles. A single article of clothing can shed more than 1,900 fibers per wash that's smaller than 1 millimeter. Studies have also shown microplastics can have presence in soil and polar regions. Microplastics in soil can eventually enter groundwater, and microplastic in the polar region can be frozen within glacier ice, which prevents its breakdown for even longer period of time. Like previously mentioned, impacts of microplastics in our ecosystem start from phytoplankton, which is an important primary producer in food web and produce food sources and oxygen supply for primary aquatic predators. Microplastics exist in our ocean, which disturb phytoplankton feeding, physical ingestion and photosynthesis by these phytoplankton. Worse still, microplastic would have toxic effects on microalgae. The smaller the microplastic would destroy algae cell wall by attaching to the surface of microalgae and hinder the exchange of ions and photosynthesis. Larger size microplastic would block the sunlight necessary for photosynthesis. On a larger scale, microplastics can be ingested by aquatic life such as secondary or tertiary predators and transferred along aquatic food chains, causing various impacts on life activities of these aquatic organisms. The impacts on these aquatic organisms include increased mortality. Human as a consumer of the above-mentioned animals, the microplastic exposed by these animals pose a direct threat to food safety and human health. Some researchers are starting to pay attention to the microplastic exposure to the air we breathe, in which has 2 particles per 1 gram of air we breathe. In freshwater streams in China, on average, you can get about 26 microplastics in 1 liter of bulk water sample. In China, you can find water samples from Xiangxi Bay of Three Gorges Reservoir or Pearl River Delta has much more concentration of microplastic particles because they share similar characteristic that they are urban sections of estuaries of river, lakes, reservoirs close to a large and densely populated city. What's surprising is that you can even find microplastic particles in very remote area like Tibet Plateau. Government of China has made efforts to control waste through the Environmental Protection Law. Amended in 2005, emphasized on sorting, separation, recycling of municipal solid waste, and reducing waste generation. Despite the effort, one might still wonder why there is so much difficulty in tackling microplastic in China. Even with so many laws and regulations exist, implementation is largely ineffective and difficult because of reasons such as difficulty to stop illegal dumpings in rural and undeveloped areas of China. Express industries such as food delivery are not yet regulated. Ultra-thin plastic. To get into how we can potentially mitigate microplastic problem with material flow approach, we need to first go over some of the concepts of MFA. MFA follows the law of conservation of matter. It can trace the process of input, export, and storage of specific substance in a country, region, or system, and analyze its transformation and migration path. In short, MFA helps us to be mindful of our materials consumptions by analyzing when, where, and how many. MFA methods include classification and statistic of material consumption data, a model that's based on EU guideline, substance flow analysis, model based on life cycle, a physical input-output table. And MFA data source includes standardized statistical yearbook, environmental quality report, and network statistical database. Research results recognized by academia and research report published by state authorities. According to the law of the sea of the world, China has a marine land area of nearly 3 million square kilometers, including internal water, territorial sea. Additionally, according to the input sources, the microplastics in China oceans can be divided into land-based sources, marine fishing activities, and ship operations. The land-based input mainly comes from plastic debris on the land and migrates to the ocean through human, wind, and river channels. The leakage of microplastics caused by marine fishing activities and ship operations is mainly due to artificial discarding of plastic products such as plastic bags, plastic fishing nets, and fishing gear. At the same time, it's necessary to consider the microplastic particle spillage caused by maritime. From 2017 to 2018, China suspended microplastics in the Yangtze River estuaries and adjacent waters for 3 consecutive seasons. In the flood season of 2019, the suspended microplastics were monitored in the Yangtze River estuary, the Pearl River Delta estuaries, the Yellow River estuaries, the Qiantang River estuary, and many more. So how do we integrate material flow approach to mitigate microplastic problem? The land-based input of microplastic accounts for a high proportion. Introduction corresponding policies and regulations to increase supervision and control of its land-based input is an effective method. At the same time, the migration process of microplastics is mainly related to the ocean current movement. The marine dynamic environment and meteorological factors should be considered in the future research of ocean microplastics. Meanwhile, reducing the consumption of single-use plastic materials, educating yourself and others about different types of plastics and their disposal processes, as well as donating instead of throwing away old-fashioned clothes, can all contribute in the reduction of plastic waste. To be mindful of our environment in the plastic usage in our daily lives does not only protect the living organisms like planktons or seabirds, it also protects yourself in the long run. Thank you for watching.